To me, I see this as a new kind of smartphone era. We're in the beginnings. There's still a lot of algorithms to be optimized, a lot of hardware to be designed and improved. Now it's a new wave, and it will definitely require a lot of engineering across the board.
From EE Tech Media, this is Moore's Lobby, where engineers gather to talk all about circuits. I'm Daniel Bogdanoff. Welcome back. I'm so excited to kick off Season 4 of Moore's Lobby. Season 3 had an all-star lineup with engineering leaders from NASA, General Motors, AWS, DARPA, Intel, and more, and we aren't resting on our laurels. This season, we got some folks lined up. Today we're going to dig into extended reality, or XR, which is kind of an umbrella term for the AR/VR metaverse space, and we're joined by an XR engineering titan, Hugo Swart, Qualcomm's VP and GM of XR. If you've ever wondered what's going on under the hood of XR, you're in for a treat. Hugo, thank you so much for being here.
No, thank you. Appreciate the opportunity to share a little bit more about myself and what I do.
So Hugo, was engineering and tech something you always knew you wanted to do?
I always actually wanted to be a business person, create something big. And I thought early in high school, I'm going to do business school. But then my dad, who's actually a professor, electrical engineering, he tried to convince me to, hey, why don't you do something technical? Get deeper into an industry and then do business. And I thought it made sense. And with my affinity with math and physics, I loved the electrical circuits class, in senior year. So it made electrical engineering the easy choice for me, and I just loved the major.
And how did you end up at Qualcomm and in San Diego?
When I was finishing school, telecommunications was booming in Brazil. Privatization was happening with the operators and lots of investment in cellular. So that's where I started working, in cellular at a company called Lucent Technologies, now part of Nokia. And one of the technologies that were starting to get developed was a new 3G standard, EVDO. So while at Lucent, I said, I want to do a master's degree as well. So while working, I took my master's. And in my thesis, I studied the downlink or forward link of this 3G, technology. How to do quality of service in the scheduler. And then while doing my research, I got into the Qualcomm.com page, looking to papers. Qualcomm was the one that really created this technology. And then I saw careers. Oh, let me look into this. And they're looking for someone to promote eVDO in Latin America. I said, wow, this is me. And actually got the job. Super exciting job. And, now almost 20 years into it.
How proud is your dad that he got you into tech and now you're doing your thing at Qualcomm?
He must be. He never actually tells me that way, but I do feel he feels proud. Actually, I took classes with him during university.
Whoa!
So I think it must be rewarding. As now I have kids. I have an 18-year-old son, and seeing what they're going to become. I mean, it must be rewarding to see that I took his footsteps into engineering, but made my own way.
So your dad was an electrical engineering professor and you took classes from him?
That's right. That's right. It was a very tricky situation because if I did bad, well, even the professor's son is not getting it. If I did well, hey, there must be something there. What is he's getting something, at home. So that was a fun experience.
Oh, I bet. How did you do, if you don't mind me asking?
A little above average. So
okay, you're doing your part.
Exactly. So I didn't create any suspicions in any side of the spectrum.
And then since graduating, I understand you've been involved in a lot of wireless and cellular technologies. Can you tell me a little more about what you did at Qualcomm before moving to XR?
When I joined Qualcomm, I was still in Brazil. And as EVDO, this first 3G technology I worked on, after it was deployed and developed in Latin America, I was invited to come to San Diego. This was about 2 years into it. And then over the following years, I was working in many new wireless technology. So at some point we had, I don't know, I mean, how far your audience remember, the early days of 3G. But in 3G, you had the CDMA CAM, CDMA 2000 EVDO, and you had the GSM, Edge, WCDMA.
Mm-hmm.
And then 4G came, and there was the GSM CAM, had LTE, and we had a new standard, UMB, and we developed a lot of technology. So I worked on that project. After that, we had a new wireless standard for peer-to-peer communication. So, today, wireless or cellular, you go to a tower, right, a base station. And then we developed this new technology where, within a 1 kilometer radius, you could tell directly between devices. And it was using a licensed spectrum, and it got incorporated into later phases of 4G and now 5G. But super interesting to think about use cases with this early technology. I really loved working on those type of projects.
So it's safe to say you're a veteran of the wireless cellular technology space. What are you doing now at Qualcomm, and how did you pivot from wireless technology to XR?
Now I run our XR business unit. We use the term XR to define virtual reality, augmented reality, and everything in between. We develop the chips, the technology, and even developer kits around XR. So I have a team of R&D, engineering, product management, and account teams, selling our products to the industry. So I really, really love it. I really feel that here at Qualcomm, I have the opportunity to change the world, which was one of the things as a child I wanted to do.
So what happens between cellular and XR?
About 12 years ago, I made a switch from the R&D side of Qualcomm, wireless innovation. I worked into our processor business, the Snapdragon side of the house, and incubating, new markets for our Snapdragon chips to be in. The first one that we had success was the TV market, right? So having a Snapdragon on a TV box, right? The first product that used our Snapdragon processor was the Amazon Fire TV. So the first Amazon Fire TV had a Snapdragon, and it was super cool because it's imagining, if I had a more powerful processor in a TV, what else could I do? How would the UI look like? What kind of new applications like gaming and so forth could be incorporated into the plain old channel up and down? So that was very interesting. And from there, we have entered into markets like drones and robotics, smart assistants. And actually, VR and AR, XR started within that role, after this transition, which was more on what we call IoT.
So it makes sense to me when I look at XR to start in cellular communication and have a background in smart TVs. All you have to do then is slap it on someone's face and you kind of have a system, right?
Yeah, simplistically, if you look at a high level, yes. Yeah, when you start to peel the onion, you see, wow, how much technology is needed for a really immersive virtual reality experience, or a light yet the rich AR glass experience. But you're right. I mean, it's when we look into XR, it's a world of technology that needs to come together. The visuals, like be it graphics or video, it's audio, it's this input technologies, like head tracking, hand tracking, world understanding. So it's way more than just the TV or the radio, but it of course we get a lot of expertise by coming from those markets.
Before we dig into this more, could you give us the Hugo Swart XR industry leader definition of what is XR?
Okay, sure. So XR, we use it as an umbrella term. If you want to know the acronym, X stands for extended reality. But I like to think more as X as the variable, and you put A for augmented reality, V for virtual reality, and then if you want, even M for mixed reality. And AR, widely understood as you have digital elements overlaid on top of the physical world. Virtual reality, a fully synthesized, fully digital world. And then MR, it's not really well or super well defined in the industry. We are using MR as a mix of virtual and augmented reality. So meaning I have a VR headset, but with cameras, with RGB cameras, color cameras, I can see the real world. So it's a fully occluded device or a headset. But with the cameras, I can see it, on the display, the real world, and then I can have augmented reality. So it's almost like MR is a feature, an advanced feature of virtual reality. So that's how we define XR. We do see that in the long run, these things tend to converge. MR is an example, but I really like to think about XR as the industry, and then you have AR, VR, and MR as a sub case.
I'm regretting that we didn't do this in VR now. I've got to pull out my headset. That would have been fun.
We should definitely try. There are very cool applications already. Spatial is one of them where, you are represented as an avatar and you are sitting together. Actually, that's one of my favorite future use cases, for VR and AR.
We'll be right back with Qualcomm's Hugo Swart. I'm joined today by Ming Su from Rohm. Ming, can you tell us a little bit about your 4th-gen silicon carbide technology?
Sure. Our industry-leading 4th-generation silicon carbide MOSFET is based on an advanced double-trench structure and is available at 750 and 1200 volt ratings to enable highly efficient power conversion.
And what are some of the performance highlights?
The specific on-state resistance is the lowest in the industry without sacrificing short-circuit withstand time. It also switches much faster, reducing the switching loss by half from the previous generation.
Half, that's significant. Is it pretty easy to drive?
Absolutely. It operates efficiently with gate voltages between 15 and 18 volt and does not require a negative voltage to turn off.
So how can power electronics designers benefit from these devices?
The new silicon carbide technology boosts performance and reduces system costs in many ways, such as simplified cooling system, smaller passive components, reduced battery capacity, and also lower costs in the power device itself.
And where are we seeing Gen 4 silicon carbide devices being used? What applications?
Many power systems can benefit from Gen 4 silicon carbide, from traction inverter and onboard charger of electric vehicles to solar inverters, power supply systems, industrial motor drives, and more.
And where should people go to learn more about silicon carbide?
Visit rohm.com for more information.
Thank you so much, Ming. It's been great having you.
Thank you for having me.
And we're back with Qualcomm's Hugo Swart. Hugo, what excites you about the future of XR technology?
The future, what excites me the most is putting people together, right? As if we were present, as if we were together. So I see my kids having so much fun with their cousins in Brazil, playing together. And, you can have play on the internet, but it's not the same thing, or me with my parents. Or now, during these COVID days, I really miss the whiteboarding session with my colleagues. So this is what really excites me is putting people together, in a virtual digital world, but have the feeling as if you were present. So that really excites me about XR, but it's not one use case. It's really a wide variety of use cases that we could stay the whole session here just talking about use cases. And what's your favorite use case?
Oh goodness. I mostly use it for like relaxation, board game, like not board game, like video game type stuff. Board
Yeah,
games a little bit, but yeah, it's mostly based on my phone. I'll have a little hand controller and play, fly a spaceship around or something.
cool.
Uh, yeah, yeah, but I'm definitely intrigued by the concept of improving those personal relationships, especially in a professional setting where I used to be able to travel around and meet new colleagues and have those like whiteboard sessions or standing together on a trade show floor or in a lab looking at a new product that's being released. That was a really special thing that I didn't realize. I didn't realize how special it was until we all got locked down and went full virtual.
Yeah. So you imagine all these classes that require a lab,
Yeah.
chemistry or, like fixing an equipment type of training. I mean, if I cannot be present, how do I do in a 2D screen? It's very hard.
Hmm.
So having a 3D environment that I have the feeling I'm handling, the equipment or doing that experiment or dissecting that frog, I think is very powerful.
One of my neighbors does memory for a tech company. He's a hardware engineer, and the company is based out on the West Coast, and we're here in Colorado. And it's been a challenge, even just professionally trying to develop that and get, hooking up a logic analyzer to a DDR chip is a very tricky thing to do in person, let alone trying to talk someone else through it on a webcam.
That's right. That's right. And we see a lot of development in training in virtual reality, be it for people that are in the factory floor. Instead of doing training on the actual product, do it in virtual reality. It's safe, and you can do as many times as you want, and you're not going to break anything. So, or even handling customer interface. You're going to be working in a shop. How do you deal with customers? So there's so many new applications that VR is enabling, and that doesn't get the limelight. I mean, I think what gets in the media is more on gaming and shooters and so forth. Yes, it's there, but it's just so many new applications that virtual reality is enabling, and augmented reality is soon start going to grow as well.
So when I think of Qualcomm, I think of this sort of telecom IP pioneer and giant, pushing forward 4G and 5G. How was XR perceived internally, and what was it like in the early days as you started to build this group?
The change from a pure wireless technology, or let's say the core, just the wireless, started, actually to happen way before XR with a smartphone. We started seeing, the old cellular phones, which were just used. You just essentially needed a modem and some processing for voice, right, and analog to digital, some processing to then you start having displays, start having applications. Now I need a CPU. Now I need a GPU. Now I need an ISP, a camera processor. So that's when we started with the Snapdragon line, right back in 2007. So then is when we started to transform our chip processor products from just modem and audio to a heterogeneous compute platform where you have all these components or subcomponents, CPU, GPU, DSPs, camera processors, audio processors, sensor processors, GPS, modem, all in one piece of silicon. And so that I think was the bigger shift. Then as we started to see that, hey, there are many other markets that need the same elements, even a drone as an example. What is the core functionality of drone? Is capturing image, as a camera. Okay, so I need a strong ISP. Yeah, I need a strong ISP, but I also need communication. Okay, I also need a DSP for autonomous navigation. Okay, I need an IA. Oh wait, that's a Snapdragon chip, so it applies, to drones and robotics. Then when you look into XR, it's the same foundational IP blocks and at very low power. Well, guess what? In the mobile phone, I also need very low power. I need a lot of integration. And actually, when we started XR, we could leverage a mobile chip. Your question is, how do we start it? How was it perceived? Well, in the beginning, if you remember, actually back, I want to say about 7 years ago, VR, you had all that hype. You had the gaming PC, type of VR, and you remember cardboard. Oh, just slap, a phone,
Yeah.
and on those clunky, lenses, and
It was so cool, though.
I know.
When that was happening, it was like, this is a sneak peek into what's coming.
But the thing is that the performance was, it was cool for maybe a minute experience, 2-minute experience.
Yeah.
But the visuals were not great. The phone would heat up. It was just not there. But then we thought, hey, if I can put a phone, in a fixture, why don't I build using that phone chip? Do a proper device with the proper lenses, with the proper placement of components, with the proper weight balance and all that. And that's actually how we started. We said the chip that we have, Snapdragon 820, that was the first one, has the kind of, let's say, the minimum bar for immersive experience. Why don't we create a kind of a prototype reference design approach? We found partners, ODM partners that wanted to work with us. And then we started shopping it around, with Oculus, with Google, with Pico and HTC and everyone else. And people were like, this can be a game changer, right? It's better than the phone, on a fixture. And is way more convenient than PC VR. I don't need all those lighthouses and setup.
Oh, yeah.
So that's how we started. And if you remember, Oculus Go was first launched, I think 2017, I want to say, which was shortly after, our first reference designs. Google had their Daydream all-in-one product, HTC, the Vive Focus. And that's when we realized we're onto something. And then a lot of the technologies that we developed for VR, the whole tracking and kind of the perception features can also apply to augmented reality. And then we said, hey, we need to get a little more serious and put a bigger effort around this. As Qualcomm, we have invested in core technology for AR, over 10 years ago, but it was more for smartphone AR. So I think the transition around 2015, 16 with the reference design, putting these technologies together, it's just started to gain more and more ground. The business started to expand. And then around 2018, 19, I was actually asked to, hey, why don't you now, instead of covering kind of these different IoT segments, just focus on XR. And I took the challenge and very happy with it.
We'll be right back in a moment with Qualcomm's Hugo Swart to talk about designing XR hardware. This podcast is sponsored by Renesas. Renesas is one of the top global semiconductor companies in the world. Renesas strives to develop a safer, healthier, greener, and smarter world, and their goal is to make every endpoint intelligent by offering product solutions in the automotive, industrial, infrastructure, and IoT markets. Their robust product portfolio includes world-leading MCUs, SoCs, analog and power products, plus winning combination solutions that curate these complementary products. And we are back with Qualcomm's Hugo Swart. Hugo, what are some things about XR hardware design that might surprise people?
Well, I think especially if you compare it to phones, right? So phones, I mean, if you look at the camera systems that are deployed on phones, they're very getting more and more advanced and adding many features. The old DSLR had, but if you look into a camera system on VR headset today, we we designed a chip, our XR2 chip, Snapdragon XR2 chip, to support 7 concurrent cameras.
Wow.
So I'm not sure everyone realize, the amount of cameras that a headset can utilize.
Can you break it down for me?
So 2 for eye tracking, if you want to track your eye movement for full vector rendering or eyes in your avatar. So that's 2. For environment tracking, at least 2. Or for position tracking, at least 2. Some people use 4. If you want to do the controllers, right? Okay, you need a wider field of view, so more cameras. If you want that mixed reality experience of the pass-through, well, then I need more cameras. It quickly adds up. And then, majority of these cameras are just monochrome black and white cameras. It's just for computer vision and AI. But if for the pass-through cameras, they're of course RGB. So that's one aspect. The other one that not many people have visibility to is the re-architecture that we have to do at silicon level on just the paths within the silicon to minimize latency, right? So in VR and AR, latency is crucial. We're talking about, there's a term called motion to photon latency, but the time you move your head to the time, the display changes, that needs to be in the order of, 10 to 20 milliseconds or even lower so that you don't get dizzy, right? You don't get the experiences that probably your cardboard days, gave you.
Yeah.
So we really have to look under the hood to chip how to cut not corners, but how to optimize the path, to memory, from the sensor, from the camera to the GPU to the display, to minimize that motion to photon latency. Even for this MR, the video pass through, we had to change the camera pipeline to minimize latency, right? So now we can get what's called photon to photon latency. The time that light comes into your camera to the time it shows up on your display, in the neighborhood of 10 milliseconds or lower. So it's big shifts. In the grand scheme of things, people may not see it, but that's the kind of technology that we have to look at. Another aspect is power is king, for us, right? If you want to have, an AR glass, maybe as small as the corrective glass I'm using here, and have all this richness that we all want, with AR, well, guess what? I cannot have more than half a watt, being consumed on the glass. So then, at least on the silicon. So then, how do you do that? Well, I cannot have a big fat CPU running all these crazy algorithms. Even if I put it on the DSP, may not be low power enough. So I need to create new IP blocks, new silicon blocks that are custom for some of these algorithms, this perception algorithms. So that's kind of a lot of behind the scenes on this journey, right? For this low power, small form factor glasses.
Half a watt is nothing for a big processor chip. That's like
I know.
That's just, yeah.
So,
Not
so
even the ballpark of what I was thinking.
of course, the processor is one piece, right, to get to these,
Sure.
holy grail type classes. I mean, the display, the optics. I mean, there's a whole ecosystem that is coming together. But we're getting there. I think devices. We're seeing a lot of progress across these technology vectors that really are going to be transformative to society.
I want to dig a little bit more into design challenges. One term I've heard is common illumination. Can you illuminate what that means for me?
Yeah. So it's about when you have a digital object, and in particular, this is applicable in augmented reality. If I have my table, I put an object, let's say a monster or something, and then if there are no reflections, there's no from the light coming in the environment, it looks fake. How do you kind of accommodate, hey, what's my lighting, where are the lighting sources of the room, and how I should apply those effects on that digital element. So that's kind of what we look at in this feature. But this is one of the features, right? I think that's there's so many others that are being worked on right now, which makes your audience of engineers, I think they're going to have a lot of fun, because we're in the beginnings. There's still a lot of algorithms to be optimized, a lot of hardware to be designed and improved, and then on the content creation side as well. So to me, I see this as a new kind of smartphone era. I mean, I grew up, or my professional life, through the smartphone transformation. Started working in the early 2000s, where 3G was a thing, and we were all envisioning, oh, what are the 3G phones going to be with this big displays and video calling, and we got there. But many people build their whole career on mobile, and it seems that we are on this new era where very same or similar vectors of technology advancements we saw now. It's a new wave, and it will definitely require a lot of engineering across the board to make it come to fruition.
So speaking of the next wave, just get right out there and ask it. How would you define the metaverse, and will it live up to the hype?
Okay, that's I guess if you ask that question to 10 people, you're going to get 15 answers. But the metaverse, I think about the metaverse as the internet in 3D, right, or spatial internet. Some people called it embodied internet, but I see it as the internet merging with the physical world. So it's persistent digital elements where you can and you are represented as an avatar. I don't think it's the dystopian kind of Ready Player One where you live inside a virtual world. Yeah, it's hard to get like a one sentence definition other than a vague, oh, it's the new mobile internet, or the embodied internet. But I really think it represents the transformation we're going from 2D computing, right? From your PC, your TV, your smartphone, your tablet. They're all 2D, and now you go into a 3D spatial environment. So that's the internet. The internet for this spatial environment. Let me tell you just a quick parallel I used with my team, just to get people, pumped up and motivated. I was reading a book of Ferdinand de Magalhães, the guy that did the world. He went on a ship in the 1500s.
Magellan.
Yeah, Magellan. Yeah, that's how you pronounce it in English. Yeah. So back then, people I was reading that book, and it kind of made me realize, 500 years ago, people were looking for the new world, right? The Americas were the new world, and you had to have, it's a multidisciplinary type of professions, astronomers, mathematicians, navigators, and to get to the new world. And to me, the metaverse, this is the new world, right? It's a new world where after is not one discipline that needs to come and figure it out. Is multidiscipline of creators and hardware engineers, software engineers, designers, and to get to this new world. So long answer, but yeah, the metaverse is coming. We like to think the metaverse, not just some people call it, oh, there are going to be multiple metaverses. I think we like to think it's one metaverse, and you have multiple worlds, multiple platforms in the metaverse. And I see myself trying to explain the metaverse like in the early days of the internet, trying to explain the internet. There are a lot of things that will come that we don't even know about.
Yeah, if all you have is a BBS message board, it's hard to explain social media, right?
That's right.
Is it true Qualcomm did custom chip design specifically for the metaverse?
Yeah, I mean, it's specifically for XR, right? The other thing about the metaverse is that, yes, it's best experienced, since it's the embodied internet, is best experienced, through VR and then, AR. But, we consider that people can still access the metaverse through a 2D screen, right? It's just that it's not going to be as immersive. It's not going to feel like you are inside the internet as much. But when we say, hey, we created, specific platforms chips for the metaverse, I kind of go back to the specific chips we have for XR. So we have the Snapdragon XR1. It's we call it the high quality tier, and then XR2, which is the premium tier. So that took into considerations all those technical aspects that I mentioned before that are different from a smartphone, and then we created this dedicated solutions. And of course, we don't think it's a one-time thing. Oh, here's a chip, and this is, of course, we're working on next generations, and there's a lot to come.
Stick around. We'll be right back in just a moment. CUI Inc., a Bell Group company, is here to deliver power when you need it. As a leading provider of AC/DC and DC/DC power supplies, CUI is dedicated to offering choice, reliability, and ease of access to their products and first-class service. Their goal is to assist you during your design process and provide the right power supplies for your consumer, IoT, medical, and industrial designs. CUI Inc. products and resources can be found through their diverse distribution network or at CUI.com. And now back to our episode. Now, I vividly remember visiting Qualcomm in San Diego when I was out of college and before I had a job, and feeling like I was in my own little skyscraper city. And little is probably not the right word, but tall, multi-story glass buildings in San Diego. And when I think of Qualcomm, I think of that scale of engineering. Can you tell me, what does it take to design a high-end chip and to get IP out there that's usable for the future? Like, what sort of teams does that take?
It's a lot of people, a lot of groups, but it starts by defining what are the use cases we are aiming. What are, and that's the challenge about designing chips, is that we need to start thinking about use cases that are going to be available 3 years from now, roughly, give or take. And then, let me do a chip that will design, that use case, 2 to 3 years from now. But then you need that use case well defined. Be it a camera use case, what kind of features I'm going to need, or what's the AR glass, what is it going to do? What are the target markets? So you need user experience people. You need product managers to kind of look into that use case and then decipher the use case or break down the use cases until the level that, oh, this is what I'll need on the GPU. This is what I'll need on the connectivity side. This is what I'm going to need on each of the IP blocks. And then you start working with the individual tech teams, and they need to, I need to reformulate my GPU architecture pipeline because of this use case that you guys from marketing came up with. And then you start, okay, once you define the logic, then okay, what is how do I put it all in a chip? And then it goes through the chip design, tape out, sending to foundry, getting the chip back, and then software. The chip bring up. I mean, there's a lot of software. It's almost I want to say almost half of the work comes with on the software side. Bringing in the OS, the key features that we want to expose. And now, with XR, not only we're doing chips, but we also are creating a developer platform. So essentially giving APIs for some of these spatial compute technologies. So it's very, very encompassing, and I'm glad you asked the question because it's very broad and requires a lot of different areas of expertise to build a chip that is usable across the board, across multiple use cases. It doesn't matter if it's for consumer, for enterprise, small form factor, big form factor. We have to take all into account and make a solution that can cut across all these segments.
When it comes to the vision of 2 years, 4 years, 10 years in the future, you work with a lot of partners as Qualcomm. Can you talk specifically about your relationship and works with Microsoft?
Yeah, we have a few very strong partnerships in XR, and one of them is with Microsoft. Back at CES earlier this year, we announced our partnership, our collaboration for a new AR chip, and also on the software side, working together between their mesh system with our Snapdragon Spaces. But it's important for Qualcomm to gather feedback from key players in the market, and Microsoft has a lot of experience in AR. I mean, going back to HoloLens and everything that they've done there. So there's a lot of learning that by working together, we can create, a better or best chip for augmented reality. And it's actually similar, with Meta, now Meta, Facebook. Back when they announced the Quest 2, they talked about our partnership for the Snapdragon XR2. Where we took their requirements, feedback, and put together the Snapdragon XR2, which, by the way, last year, the Time Magazine considered it one of the greatest inventions of the year.
Snapdragon 2.
That's right.
That's super fun. Have you ever talked to Mark Zuckerberg about XR?
We work very closely with his team. He is super knowledgeable on XR, and we really thank him and Meta for the whole investment in the space, along with some other key companies that are moving the whole ecosystem forward.
So is the term metaverse just a Facebook thing, or is that kind of the general term that has been maybe not co-opted but adopted?
It is very much an industry-wide, or even regular people on the street now, hear the word metaverse, and you see, Qualcomm talking about the metaverse. You see, Microsoft, China, all the key China players also talking about the metaverse. Operators, content creators. So I definitely think it's not, just a meta definition. It's really an industry wide term that it's going to be as much used as the internet.
It's kind of a scary thought. Is there anything that scares you about the future of the metaverse?
Well, there is. I think I'm more positively excited about the opportunity of merging, physical and digital. But it does scare me of a world where all our production is automated, from crops to, physical goods that get automatically delivered to your house. And you basically don't have to leave your house, and you just live in a digital environment. That scares me a little bit when I sometimes see kids that stay the whole day in front of a computer. Hey, what if it was inside, the metaverse? That scares me a little bit, but I'm optimistic. I think that people will still want to go outside, want to be in nature, and just use, the metaverse to enhance those experiences.
Let's talk use cases a little bit. We can just I'll throw some out, and I'm curious to get your thoughts and things you might be excited for, or things that might surprise our audience about
Sure.
these different use cases. So the most obvious one, of course, entertainment.
Yeah, entertainment. I think sports. You
Oh,
can already watch live NBA on the Quest 2, but I can only imagine the day where you're going to have the resolution that, your eye resolution, and just like have exactly the same feeling as if you were, in the arena. We're getting close.
interesting. My father-in-law got himself a pitching machine that goes up to 90 miles an hour, and over Christmas we turned it up to like mid 70s, and it was terrifying to be within 10 feet of the ball. So I imagine a VR AR type scenario would be really interesting to sit through, especially to put yourself maybe on the field as a batter with someone throwing 100-mile-an-hour fastballs by your head. Okay, travel.
I love travel. I would love to go to real, places. But what if I can't, be in Antarctica? What if I can't be in the moon? Hey, what if I can use VR, to at least get some of the experience? Or what if I can use VR to really check out this place before I go? If yeah, this is the place I want to go.
Mm.
So I think travel in VR and then travel with AR. Imagine being in ancient Rome or being in Rome, and then have overlays on top of ruins, right? Reconstructing how it was before.
Oh.
So I think those are two great examples, for traveling VR and AR.
I know when I travel to non-English speaking countries, just being able to hold my phone up and viewing a English translation of signs or menus has been incredibly useful. So having that seamless would be fantastic. What about healthcare?
Healthcare, every day seems, or at least every week, I see a new use case on how VR and AR are helping, in the medical field. One of my favorites is a partner of ours. We work with a company called Penumbra. They work with stroke medical equipment, for strokes,
Hmm.
and they saw the opportunity for stroke rehabilitation using virtual reality. So instead of working with physical therapy, traditional physical therapy, you can just put a VR headset, make it into a game, tracking exactly the movements of the person trying to get rehabilitated,
Hmm.
and put the experience, the game experience, forcing the person to move a little bit higher every day or move their arm a little bit stronger every day. So really, that use case really, I think, moved me, showing how the technology they were working on is helping patients.
Yeah, amazing. Seeing progress when you don't feel like there's progress must be helpful there. Is there a use case that you're really excited about, but maybe the average person hasn't even considered?
Well, I think the use case goes back to the one I referred to in the past, which is related to social. I built through my childhood very strong friendships, and till today, but very hard to get together with them. So I can only think about the day where we can all feel like we are on the same table, have a beer, and each one in our own place, but we see each other as avatars, as if we were in the same table. So that's kind of the one that keeps me looking forward to the metaverse.
Can you share some vision for us? What do you think the metaverse will be like in a year, in 10 years, and in 100 years?
Okay. In 1 year, I mentioned before this MR concept, right, of VR headsets with video pass-through. So I think we're going to start to see products like that in the market and start, bridging that augmented reality with virtual reality. In 1 year, we're going to start to see AR glasses that wirelessly pair with your phone. So basically, where processing is not done only in the glass, but distributed between the glass and a phone or a nearby compute host. So that's, I think, within the 1 year kind of a realm. With the 5 year, then you start seeing, AR glasses, with 5G, that you have a split compute, not only between, your glass and, a near proximate host, but between your glass and the edge of the cloud. In the virtual reality space, looking to very high resolution displays that start getting to eye resolution in certain cases. Now, I mean, beyond the 5 to 10 year horizon, I think in 10 year we kind of start seeing convergence of VR and AR and getting to the glasses that we all, that we all want. But then if we start looking even further ahead, then we start thinking about, hey, even, do I need a glass? You start thinking about implantable technology, brain-machine interface. Actually, I try not to think too much, because that is kind of scary.
Fair enough. I'm thinking through, Elon Musk mentioned wiring directly into brains and that sort of thing, which is a terrifying thought. I don't know that I'd want electronics in my body, but in 100 years, technology might be there.
Yeah.
Can you share your most interesting VR XR experience that you've personally had?
It was actually bringing home my VR headset, and kids start calling it the new world. And this was like 4 years ago. So, that to me was remarkable, saying, yeah, this is the new world. Going back to, the parallel I mentioned earlier.
Do you enjoy watching videos of people with VR headsets running into walls, or is it just me?
I do. I wish, I've seen people in real life giving punches in walls and all that kind of fun, but sometimes, even harmful. But it is kind of fun.
I have had bruises from hitting pieces of furniture.
That's right.
So I'm in that group. Brazil, famous for food. Near and dear to my heart is the churrascaria. Anywhere in the U.S. that you can recommend, or San Diego area, for Brazilian food?
Well, I think Fogo de Chão is, the most popular, churrascaria nowadays.
If you could put any time and place in history into a VR headset, where would you go and what would it be?
I think it would be, the Americas right before, Europeans coming, seeing how they lived, in their ancient societies. I think that would be a very interesting moment in time to look back and how, Europeans transformed the continent.
That would be fascinating. Hugo, thank you so much for being here. This has been amazing.
No, thank you. I appreciate the opportunity. Looking forward to work with the many engineers listening to help build the metaverse.
Thank you for listening. I hope you're now as fired up about XR as I am. The pivot from pure smartphone tech to extended reality is definitely something I'll be watching closely as it develops. In our upcoming episodes, we have some guests you won't want to miss. We'll be talking chips, AI, and outer space. And if you could do me a favor, share this podcast with someone you think will like it. It really helps us grow. And I've got something special for you. If you go give Moore's Lobby a review, I will send you a brand new Moore's Lobby mug. Just leave a review, drop us a message on social media so we know you did it, and we'll send a mug your way. Do it quickly before I run out of them. I'm Daniel Bogdanoff. Thanks for joining me today in the lobby, and I'll catch you next time.